take a look at this Poisson distribution. A Poisson distribution is just slightly different from that binomial. Okay, so in the Poisson distributions, mainly we just look into the mean values. Okay, for example, in the probability distribution, we know that the discrete random probability distribution, first is the binomial, the next is Poisson, and the continuous, we have the normal, uniform, and the exponential. So now we're going to look for this. Okay, we already done this. Now we look for this. All right, now Poisson probability distribution, all right, can define as the Poisson distribution random variable, often useful estimating the number of occurrences over the specified interval of time or distance or space. So this is very important. It's just mainly specify or the average specified of the times. Okay, the average values of it. So this is discrete random variable that may assume that the infinite sequence from 0, 1, 2, and so on. Okay, so these are the condition of this Poisson distribution in this section. Okay, now the property of the Poisson experiment, all right, as you must understand that first experiment consists of the counting the number of times an event, which is x, and it is occur in a given interval. Okay, and its interval can be an interval of the time, area, or volume. All right, so it's we just with the lambda. All right, is represent for the mean values. Okay, remember that. Next, the probability of that occurrence is the same for the any two interval of the equal length. Okay, so that is the conditions. If the x is the number of occurrence in a specified interval, then x is called as a Poisson random variables. Okay. All right. For example, the number of computer crashes in a day. So we see the number of computer crashes in a day. So in a day, how many number of computers crash? Okay. That is applies for the following day as well. And another example, the number of car accidents per month. So it means we just take that 1 month's value in order to represent the upcoming months. Okay, and roughly we know that calculation. So it means the mean value is the subject. You need to understand that that is the average values in order to consider for the calculation. All right. So the formula. So we have the Poisson formula. So it will be probability of that any of the random variable x is equivalent to exponent. All right, exponent of minus lambda. Okay, the lambda is the mean value. All right, is the mean value. Okay, multiply by the lambda power of x. Okay, over the x factorial. Okay, so then x stands for the number of successes per unit, and then the lambda is the expected number of successes per unit. Okay, or we also can as the average number of the occurrence in the specified span of time, space of distance. And then the E is stand for the exponent, all right, exponential, all right, value, which is based on the natural logarithm, which is equivalent to 2.71828. Okay, it's a value. All right. Now take a look at this example. So suppose that on average 5 cars entering in the parking lot per minute. Okay, so 1 minute about 5 cars enter. Okay, what is that the probability that in given minutes 7 cars will enter? So now we're going to calculate the probability. Okay, so we know that the mean value, which is 5 cars enter per minute. All right. So what is the probability of 7 cars enter? Okay, so we're going to calculate that. All right, now we use the formulas. So the probability you're getting the 7 cars enter. All right, so what the chances? So it's very simple. You just write the Poisson equations formula. All right, and then the substitute the average 5 cars enter per minute. So that means minus 5 multiplied by 5 power of 7. So x is 7 cars. over 7 factorial, and you get a 0.104. So which means the probability, okay, the probability of 7 car is entered the parking lot will be 10.4%. Okay, so then you can also say that there is a 10.4% chances where 7 cars will enter the parking in a given minute. Patient arrived at the emergency rooms of the Kampa Hospital at the average of rate of 6 per hour, right? 6 per hour, that means 6 people per hour on weekend evening. Okay, now what is the probability of 3 arrival in 30 minutes on the weekend evening? All right, so this is the information that we know. First, you need to write that. So average, okay, 6 in 1 hour, okay, which means for the half hours for 30 minutes, we already know that is a half of it, right? So 6 divided by 2, so we got a 3, okay? So half hours, so half hours, so we got a 3 patients, okay? All right, now, so we have a x is equal to 3. Now, we're going to calculate that the probability of 3 arrival in 30 minutes on weekend evening. So then you just substitute 3 patients. So now we have a new average value, which is E into lambda multiplied by lambda x over x factorial. So we just substitute those values into it, and we get a 0.224, which means you can conclude that you have a 22.4% of the probability of 3 arrival in 30 minutes on weekend evening. So for the mean, all right, the expected mean for that, the Poisson equation is simple. Use the mu is equal to lambda itself. There is no change. And the variance, all right, is equal to lambda itself. And the standard deviation is square root of lambda, all right? Is everything the same values for the Poisson equation, all right? Okay, guys, that's it.